Hey scholars, welcome back to Chapter 8. We're looking at 8.2, why are marine aquatic systems important? We're also going to take a look at some threats to marine aquatic ecosystems in 8.3. We're going to combine these two sections today just to kind of keep it all in the marine aspect. So that's our question, why are marine aquatic ecosystems important, and then how are they in danger? Oceans provide important ecological and economic resources. There are reservoirs of diversity. There's three major life zones within oceans. There's the coastal zone, which usually has a very high NPP, going back to chapter 4 of our textbook. So high net primary productivity, very lots of energy transferred from organism to organism. And then an open sea is the second one, and then we have the ocean bottom. And so those are our major three areas of diversity. And so we're going to explore some of those throughout this section. You can see the services provided just by marine systems, and we'll compare those to just freshwater systems. But climate moderation, CO2 absorption, nutrient cycling, waste treatment, reducing storm impact, like we talked about earlier in chapter 14, habitats and nursery areas, especially in those mangrove forests, and in the coral reefs, genetic resources and biodiversity, and also scientific information. Lots of all that are ecological services. Now, on the economic services side, we have food. A lot of our animal food and pet foods, like dog foods and cat foods, come from marine ecosystems. Pharmaceuticals, harbor and transportation routes from getting from point A to point B and getting things moved across the world. Coastal habitats for humans, recreation, employment, oil and natural gas harvesting, mineral harvesting, and also lots of building materials. Those are our major ecological and economic services that are provided by marine systems. This is a look at kind of the vertical zones in an ocean, kind of by depth and also by how far away from the coast they are. It also looks at temperature as well. So you can see at the top here, right at the surface of 0 depth in meters, we have the coastal zone. It's the one closest to the shoreline. Even closer to that is the estuarian zone, or estuarine zone, where actually you do have, that's even the closest to the shore. You have lots of, we call this the coastal zone, where high tide and low tide meet in that estuary zone. And we have lots of a diversity of species, usually kind of where coral reefs are found. Then we have our open sea. This is called the continental shelf, kind of where that drops off. We have the open sea out here, down about 0 to 200 meters. That's a lot. We call this the euphotic zone as well as the open sea. This is the euphotic zone because the light is penetrating all the way through, and you can see that keeps the temperature relatively warm as well. Then we get down deeper, from about 200 meters to 1,500 meters, and that's what we call the twilight or the bathyal zone. And you have that's where your temperature is it's starting to drop tremendously because there's no longer any light there, or there's twilight, so there's some light coming through, but not nearly enough, and it even gets less and less as you go deeper in this zone. So water temperature drops. We call this the thermocline. In this area, so that's where we have a steep drop. There are some organisms that are best suited for that bathyal zone, and then going even deeper, 1,500 meters all the way down to the deepest of the ocean can get is called the abyssal zone. It's complete darkness. Organisms have adapted to meet the different, the rays of the no light in that area. They've adapted to meet the cold temperatures as well as the lack of light. And so those are our major zones. The estuarian zone, which is kind of part of the coastal zone. Then we have the open sea, the euphotic zone. There's the top part, the middle is the bathyal, and the bottom is the abyssal. So estuaries and coastland wetlands are very productive, high NPPs. They have, this is kind of showing you where this is at. This would be river mouths or inlets, bays like the Wilson Bay, different sounds like the Almar Sound, salt marshes, mangrove forests. All those would be kind of estuary. It's kind of brackish water, part salt, part fresh, depending on the tide and when it's coming in and out. The seagrass beds that are in these habitats support a variety of different marine species. They're very good at kind of housing juvenile fish and kind of giving them some protection against bigger fish. They stabilize shorelines, which allows for less erosion to occur, and they also reduce wave impact. So it's important to keep those seagrass beds of estuaries intact to help reduce erosion further inland on the shoreline. They're also really good at filtering things. They filter out toxic pollutants. They kind of grasp excess plant nutrients and sediments. They keep all those housed in there. They absorb lots of pollutants. They provide food, timber, fuel wood, habitats. Again, they reduce storm damage and coastal erosion. So very, very important habitats. Unfortunately, those are the ones that are being destroyed the most because of humans moving to those locations. This is just an aerial image showing you of an estuary from space. You can see all the sediment that is moving down all through these streams, then kind of depositing out here. Luckily, for these, there's a lot. This is kind of an area there would be a lot more. All of this would be out there, but there are some seagrass beds that can absorb those things. That's kind of where those rivers dump into the ocean. That's an example of an estuary. This is just a food web that looks and gives you also an image, which you see a lot of here in coastal North Carolina. If you drive over the Emerald Isle Bridge, you look out, you see exactly this. This is just showing you on the left image a food web of all the different organisms that kind of interact with one another as far as energy-wise in the food chain of a marsh ecosystem or an estuary. This is a great look at the mangrove forest and what a mangrove plant looks like. If you notice, it has extraneous root systems that hold in the sediment, which is very, very important. And they do a very, very good job of holding it. Unfortunately, these trees have been also taken out for coastal development as well. This is just looking at one area in Queensland, Australia, where they're still intact, which is kind of cool. Rocky and sandy shores host different types of organisms. The intertidal zone, where we actually have two different types of shores. We have a rocky shore or a sandy shore, or we call barrier beaches, and that's what we're most familiar with here in coastal North Carolina, those sandy shore barrier beaches, or those barrier islands you've heard so much about, and that you've explored probably your whole life. Organisms adaptations necessarily to deal with daily salinity and moisture changes, so as the tide goes in and out, organisms have adapted to deal with that change, and that daily change, actually. And the sand dunes are very, very important as well, because they allow, again, for blocking some of that, the erosion taking place, some of the water that's coming up, those highs and low tides, kind of keeping the rest of the island protected from that water that's hitting it on a constant basis. This just shows you the difference. This is a sandy shore beach or a barrier beach and a rocky shore beach. And you can see the kind of the difference. These organisms have majorly adapted to constant harsh wave action. Obviously, as the water breaks on those rocks consistently, that's a lot. I don't know if you ever get beaten down by a wave. I have. It doesn't feel very good. And those organisms have adapted to taking it every single day, all day. And these organisms here have well adapted to kind of, and these two as well, have adapted to long periods of no water. And then some periods of lots of water. So that has been another adaptation. You can see some of the different types of animals that have made those adaptations in those areas. This is a look kind of at a cross-section of a dune, which are extremely important. And you can see this looks just like our dunes in North Carolina, or at least our islands in North Carolina. You have the ocean here, a beach where there's supposedly and hopefully no building, a primary dune where there should be no building, and walkways, grasses, or shrubs are heavily planted there to keep that dune intact. And that's the dune that protects the rest of the island from especially from hurricanes and those things, from the impact of those waves. Then we have a trough where there's limited recreation and walkways, still shouldn't be any buildings, some taller trees and shrubs, and then a secondary dune where there's, again, no walkways, no buildings, and a lot of times when hurricanes come, this area will flood out, and it's important not to build there. And the back dune, which is the most suitable spot if you were to develop on one of these areas, right next to the bay or the lagoon or the sound side you guys are familiar with hearing about. Unfortunately, if you look at all of our islands, most what happens is people build right onto this. And that, again, puts them in high danger for hurricanes, and also puts the dune and the rest of the island at danger as well. So we because of our influx to the coastal areas and because of the pretty views, we've decided to build on where a dune that really shouldn't be built upon. And you can see this along Emerald Isle or Topsail or Sneed's Ferry or anything else like that. Coral reefs are amazing centers of biodiversity. Again, they're kind of the marine equivalent of the tropical rainforest. They have a ton of different species living there. They actually have 1/4 of all the marine species that inhabit that area. So really, really cool to talk about coral reefs. They are very, very important to us. And then this, again, just shows the interaction of organisms within a coral reef and shows some examples of organisms that live in coral reefs and the energy flow through that ecosystem. The open sea and the ocean floor host a variety of species. Again, we're going back to these zones again. The euphotic, which is the top zone of the open sea, which has to do with light and the light penetrating all the way through that zone. The bathyal zone, the twilight zone, kind of in the middle somewhere, having a little bit of light, but not nearly a lot of it. A lot of bigger organisms like squid and things live in the bathyal zone. Abyssal zone receives what we call marine. So that's all the dead organisms that have died and they're kind of freely falling. If you ever watched the movie Titanic and they're down there looking for the Titanic, you saw this looks like space or stars flying through. That's the marine snow. They're just organisms that have died and now are slowly falling to the bottom to be fed upon by what we call filter feeders or deposit feeders, kind of the decomposers of that ecosystem. There's also upwellings that can occur here where currents that will swoop down and actually bring up some of those nutrients and bring them up into the bathyal and euphotic zones, which have some nutrients there. Also can cause die-offs and some things. So there are some goods to upwellings. There are some bads depending on what's being brought up and how much is being brought up. But but as far as primary productivity in MPP, the euphotic has the most because obviously it has the most producers that are harnessing that sunlight. But that's just a little bit about the marine ecosystems. So let's take a look now at how human activities have affected, maybe positively, probably more so negatively, of these different ecosystems. And some major threats are the coastal development, overfishing, runoff from non-point source pollution, which is very hard to control and stop, point source pollution, habitat destruction, especially on those dunes we talked about, introduction of the invasive species, which we're going to get to in a little bit, but that's basically bringing in species that were not normally there at one time. And one great example of that on the North Carolina coast is the lionfish. Climate change from human activities, and then pollution of coastal wetlands and estuaries, over-polluting, because I know they can handle some pollution, but not the amount that we're putting in there. And then the case study, the Chesapeake Bay, an estuary in trouble. Just north of here, a couple of states north, it is the largest estuary in the United States. It's been polluted, heavily polluted since 1960. The population has increased around that area. Point and non-point sources raise pollution. One of the biggest things, I was walking around Baltimore, which was on the Chesapeake Bay, and I was doing a little city tour, and it's a beautiful city, but when I looked into the water, I couldn't believe the amount of trash that I saw living, that was just free floating in the bay. All the stuff from the city, a lot of it, a lot of that trash that was just flowing in the streets gets blown into the water and it sits there, which causes major problems for organisms that live there. The phosphates and nitrate levels are way too high for that area as well. It's been overfished. In 1983, the Chesapeake Bay program started. They were trying to figure out how are we going to clean up the bay. It's been polluted. They introduced some Asian. They were thinking about introducing some Asian oysters, which are much bigger, can filter out water, even though the native oysters are there. So that started in 1983, and you can see the amount of area that was very, very what we call anoxic, no oxygen off the coast. So very, very polluted. There are some low oxygenated areas as well. And there's Baltimore included in there. So very, very, very detrimental bay. It's the largest, and I feel like we should definitely put forth some more effort in protecting it. Even now, even though I just visited there a few months ago, and it was still not nearly as clean as I would like to see it. I'm sure the organisms are having a problem with it too. But that concludes our talks about marine ecosystems. We'll see you again next time for freshwater ecosystems.